Well, hello. Welcome to lesson 10.4, which is perimeter and area in the coordinate plane. So the objective for this lesson is I can find the perimeters and areas of figures in the coordinate plane. Okay, so let's look at a warm-up to review some ideas that we will be using today. All right, so the first thing we want to do is determine the slope of this red line. So I'd like you to pause this real quick and see if you can determine the slope. Okay, so to determine the slope, we just need to go from one known point to another known point. So I'm just going to go from here, and I don't know, I'll pick this one down here. And then so we're going to go down 2, and then right 4. And so the slope would be negative 2 over 4. That can simplify to negative 1/2. So the formula for this could be the change in y over change of x, or you often see it as y1 minus y2 over x1 minus x2. Okay, the next question is, what is the length of the red line segment? So I'm going to start by marking the 2 endpoints, listing the vertices. So negative 4, 4, and 6, negative 1. Okay, so there's really 2 main ways of finding the length of this line segment. The first one is using the distance formula, which is this kind of messy looking formula here. So the distance will equal, and take the x value from one of the 2. So I'll start with this one up here. This will be negative 4 minus 6. I'll square that and add that to the y value, 4 minus negative 1, and square that. Well, negative 4 minus negative 6 is negative 10, and that squared will end up being 100. Then this part here, 4 minus negative 1 is 5. 5 squared is 25. So now I'm just going to simplify that radical. Ends up being the square root of 125. And that can simplify further to 5 root 5. And that's approximately 11.18. And I almost always still figure out what the approximate value is, just so I can make sure that it looks reasonable with the length. Okay, so that's one method of doing it. The other method is to consider a right triangle. And so this length is 5, this length is 10. And then I'm going to mark this D up here because that's what we're trying to find. So now it's just going to be a squared, which is 5 squared, plus b squared equals c squared. And then it's going to simplify that. Left-hand side equals 125. So take the square root of both sides. That would make d is equal to square root of 125, which is the same thing as 5 root 5. So you can use either method. Sometimes this one here is easier when it's plotted for you. And often this one here might be easier if you're only given the coordinates. So let's look at how to estimate areas of irregular shapes. So there's a couple of ways of doing this. The first method is to divide your irregular shape into shapes that you are familiar with, which are shapes that you can easily calculate the area for. So usually that's going to be rectangles, triangles, and trapezoids. So I'm going to draw my shapes on here, and inside each of the shapes I'm going to write the area inside of it. And it's going to do that until the whole shape is filled. Some parts I'll have to estimate, and especially like the half ones, and sometimes it's even your own, not everyone will necessarily divide it up the same way, but it's just an estimate, so that's okay. Okay, so now that I have all that done, just going to put all those into the calculator and add them up, and we get 44 square units. Okay, so another method is to just count the squares. So we're going to count half squares and the whole ones. There won't be any in between. So I'm going to first start by putting a little blue dot on all of the half squares and add up the area of all the half squares together. So I counted them and I got 11 half squares. So the area of all of those half squares is 5.5 square units. Now in green here, I'm just going to put a dot on each of the whole squares, and I'm just counting that number to myself in my head. So then I get 39 whole squares. Then we just add those two together and get 44.5 square units. And if you look carefully, the difference will come up in this area here. And the difference is actually okay too, because it is just an estimate. So here we're asked to draw and classify the polygon with these vertices, and also find the perimeter and the area of the polygon. So to draw, we're just going to plot those points and then connect them with line segments. Okay, so the next thing we want to do is classify the polygon. And just by looking at it, it looks like it is probably a parallelogram. So the property of a parallelogram is that the opposite sides of the quadrilateral are parallel to each other. So I want to make sure that each of these parallel lines will have the same slope. So the slope of HE will just be the change in y over change of x, and that will equal 2 over 3. 2 over 3. Okay, and then the slope of GF is also 2 over 3. So therefore, these two lines are parallel to each other. Okay, so the slope of HG is -1/3. And the slope of EF is also -1/3. These are parallel to each other too. So therefore, this is a parallelogram. All right, so now we're going to do the perimeter here. And to do that, we need to know the distance between each of the vertices. So I am going to use the distance formula to help me with this. So I also know that the distance HE is equal to GF. And that is because it is a parallelogram. And so HE is equal to square root of, look at these vertices here. -4, -3, and this one here is -1, -1. So x1 minus x2 squared plus -3 minus -1 squared. And this ends up being -3 squared plus -2 squared. 6 the square root of 13. Oh, 3.61. Okay, so then we want to find EF. So EF is equal to HG because it is a parallelogram, and EF will equal, let's see, so this is 2, -2. So 9, this would be 3 squared, and then this would be 1 squared. So square root of 10. It's about 3.16. All right, so then the total perimeter is equal to our 3.61 plus 3.16, but then double that, because that was just one of each of the parallel lines. We got 13.54 square units. Okay, so finally the area. I think I'm going to try to squeeze that over here. I'm just going to break this into triangles. There's a triangle on the left and triangle on the right. And they will be congruent to each other. And so that would be the height of the triangle there. So the area will be, well, the area of one of those triangles would be 1/2 the base times the height. But we have 2 of those triangles. So the area would be 9 units squared. Okay, so here's another one where we're asked to draw and classify the polygon with those vertices and find the perimeter and area of the polygon. So first we're going to draw it like this, and then we're going to work on classifying it. So when I look at this, it looks like it is a rectangle. And so what I want to do to classify this as a rectangle is verify that each of these are a 90-degree angle. If they are, then we're done. Okay, so then the slope for each of these, it's going to calculate it for each of them and then with an arrow to that line. So the slope of this one here on the left goes up 3 and over 6. So the slope of that will be 3/6, which we can simplify to 1/2. Okay, now I'm going to come down here, this bottom one, and that's going to be the same thing, up 3 and over 6. 3/6. So I'm going to say the slope of AB and DC is equal to 1/2. So now we want to look at the slope of AD and BC. Over AD, we go down 4 and over 2. So the slope will end up being -2. And BC is going to be the same thing. So the slope of those is -2. So as we go around the triangle, this is slope 1/2, and this was -2. This is 1/2, and then this one here is -2. And so 1/2 compared to -2 are opposite reciprocals of each other. And if slopes are opposite reciprocals, that means that the line segments are perpendicular to each other. So now I can say that since the consecutive sides are perpendicular, then triangle ABC is a rectangle. Okay, so what I'd like you to do is determine the perimeter and area for this rectangle. And then in a sec here, I'll put up the answer so you can compare it. So here we have to find the area of the polygon with these vertices. So I'm just going to start off by plotting those points and then connecting them with line segments. Now to find the area, I could break this up into familiar polygons, maybe like a trapezoid and a triangle. But I'm going to show another method that you can use to find the area. So I want you to consider, what if we box this in to a rectangle? And the reason why I want to do that, because the area of that rectangle is pretty easy to calculate. In this case, it would be 9, that would be the base, times 7 for the height. So we get 63 units squared. Okay, so now if I subtract out this area here and this area here, we'll be left with just our figure. So the area of this guy here would be 1/2. The base here, we want to consider that to be this left-hand side here. So 1/2 times 4 times the height, and that's going to be 6. So the area of that will end up being 12 units squared. This one here will be 1/2. See, so that base will be a 3, then times 7. So that will equal 10.5. So the area of our polygon will equal our 63 minus the 12 minus the 10.5. So we get 40.5 square units. So on these problems, the key here is really how you break it up. And there's no one way of doing this. You could do this by bringing up the inside and get the same answer.